Howdy, it's Tubalcain, and this is tips number 183. Now be sure and go back and watch 182 if you haven't seen it already, where I cut this thread using a carbide type cutter, and I promised in that video that I would come back and show you different ways of measuring threads other than just running a nut on there. And quite often that's all we do, is run a nut on there when we cut a thread on a lathe, and probably 95% of the time that's good enough. But there are many other ways of measuring threads other than that, and we'll discuss a few of those, 4 different ones actually, using a thread micrometer, thread wires, using thread ring gauges, go and no go, and thread triangles. So let's talk about all of these, but first a few things about thread nomenclature that you need to know. You know, men have spent their whole lives studying threads, and there are entire books devoted to this, so you can get pretty deep into it if you want, but just briefly here, some of the thread terms. The major diameter is the maximum outside diameter of a thread. The minor diameter is the minimum diameter from the root on one side to the root on the other side, and the root is the low spot and the crest is the outer high spot. The pitch refers to the distance between one thread and another. In the metric system it's really simple because it might just be 1.5 millimeter pitch, and that's the distance from one to the next, but with our imperial system it's a number of threads per inch. For instance, 10 threads per inch would be 1/10 of an inch or 100,000ths of a pitch, but the other fractions are a little more difficult to calculate. Well, there's some other things mentioned here too, the thread angle and so on, but one of the main ones you need to know is the pitch diameter. And the pitch diameter is nothing more than an imaginary line that is halfway between the crest and the root, and measuring that determines how accurately a thread is made, and that's often what they're using in industry, is the pitch diameter. And all that information can be found in books and in charts. I showed this in the last video, Practical Machinist Guide, Machinery's Handbook, and they will all devote many pages to thread dimensions. So study up on that if you need to. Otherwise, let's take a look at how to measure these threads. This is the 9/16 thread that I cut in the last video, and I cut it such this commercially made nut from a hardware store would fit on easily, and it does. And these nuts, and the bolts for that matter, that you buy at a hardware store are always made to their specification, which are going to be loose enough so they're going to fit when they get them out in the field, and they won't be troublesome and have to be reworked. But they tend to be a little sloppy, but yet if you could measure the strength on them, I'm sure that they're probably 90% of the maximum strength that you could really want with a thread that size. But let's look at the dimensions now. A 9/16 18 unified national fine should have a major diameter of 562, a minor diameter of 490, and a pitch diameter of 0.526. Now if you look at these gauges, we got a red one is the no-go and the green is the go, just like stoplights, and these are thread ring gauges. You can also get these as plug gauges for internal threads. But if you look on here, it tells you the size, 9/16 18 unified national fine, and that's for a 2A fit. I'm not going to talk about fits because that's a whole different subject, but for go, the pitch diameter there is 0.525. Well, that's within 1,000th of what I showed you here that I took out of the book, and I have rounded some of these off. So that's the pitch diameter, but that means that that should fit on, it should go, if it's cut to the correct depth. And you can see it goes right on. And that's good. Now normally these won't be at every machine in a factory. They're going to be used in the inspection department and probably when they set up the machines, because these are pretty expensive and they would probably spot check the bolts as they came off just every so often. And then these can be recalibrated, and when they're calibrated then wax is put in there to make sure that nobody tampers with them. Now this is the no-go gauge, and again the size and pitch diameter of 520 and a half for that matter. Now that should not go on. Whoop! I picked that up. Darn gravity. And it doesn't go on. It goes on about a half a turn. So that is the no-go. And according to that, this thread is within the specifications. Now there'll be a drawing that'll have specifications and tell you what the dimensions should be, but that thread is just fine. Now let's take a... I didn't really measure it. I just determined that it's within the tolerance with these. So let's take a look at a different way of measuring it. This is a set of thread wires, and I bought these at a swap meet, and they've been calibrated in '09. That looks like a Caterpillar type of calibration there. I think the guy worked at Caterpillar. I hope he owned them and didn't just take them home. But inside there are, perhaps a dozen or 20 different sets of wires, and there's 3 in each diameter, and they're marked as such here. And then it came with a little chart, and in the chart you look up what thread you are trying to measure. This is kind of oil soaked. Well, the ones on the left hand page are for metric, so we don't care about those, but in this chart right here we would look up 18 threads per inch, which is right there, and it tells us to use the 32 thousandths wire. I've already taken those wires out of here, that's why there's an empty spot. And then there's a little formula here that you need to use, and I'll get to that in just a second. Thread wires are difficult to use, and they're difficult because you need 3 hands. Now sometimes this will still be in a machine or in a vise or whatnot, but you still have to hold the 3 wires in place and then a micrometer to measure across the 3 wires. And that can be pretty difficult. So my way of doing that was to take a piece of plastic here, and I used very small drill bits, just a little bit less than the diameter of the wire. I drilled some holes in the appropriate spot, and you can see there's 2 wires on one side and 1 on the other, and that's going to be very easy to hold. Now some people use rubber bands, they use clay, they use wax, and if you're dexterous enough you can just hold them in your fingers, but I don't have the practice to do that. So this is what I came up with. It's a nice way to hold them. I think there are commercial ways of holding them, but you need different size plastic here for whatever diameter wires you're using or whatever the diameter of the thread is that you are trying to measure. But that's my way of holding them. If you look at this little chart that came with the wires, you can see the cross section of the 3 wires there, and now those are the anvils of the micrometer on the top and the bottom here, one my thumb is on. And that's basically what I'm doing here right now, is I'm holding those little wires, 2 on one side, 1 on the other. And this works slicker than can be with this little piece of Delrin that I've got here. And my dimension is 571. I'm going to write that down, and that's for the commercially made bolt, and then I'm also going to measure the one that I cut on the lathe yesterday. Looking at the threading chart now for 18, there's a constant in this column, and the constant is 0.04789. I'm going to rounded off to 48 thousandths, and that needs to be subtracted from the dimension that I came up with here on the micrometer. So I have done that, and that was 571 minus the constant of 48 thousandths. So I come up with a pitch diameter for this commercially made bolt of 423. Now the actual pitch diameter should be 526. That's only 3 thousandths off, so that's mighty close. You know, just 1.5 hairs, 1.5 human hairs off. And they have to allow for plating also in the plant, the thickness of the plating. So that's really a good job of what they did there on that commercially made bolt. Now let's do the same measuring to the one that I made. Now I'm measuring with the 3-wire system. And it sure helps if the work is held like that. And I'm getting 572. And looking at this now, the red is mine and the top one is the bolt I did a minute ago. So subtracting that constant from the 572, I come up with 524. That's only 1,000th difference from the what I thought was kind of a crude bolt. And pitch diameter should be 526 to be perfect, so I'm within 2 thousandths. And I would say that is just fine. And that's how to measure with the 3-wire system, the dreaded 3-wire system. And you can get these for $10 or $20 from any supplier if you have a notion. Let's move on. I bought this Starrett thread micrometer several months ago. Now you might have to have a whole series of these micrometers because this one has a range of from 8 to 13. You can buy micrometers that have extra anvils. It's a whole set, so that's really what you would need. But for a specific job, this is the one that would handle anywhere between 8 and 13 threads per inch. And I'm going to measure a half 13 bolt, so that's within its range. Notice that there's a 60-degree V on this anvil and 2 little V's on the fixed anvil. Now that rotates a little bit if needed. That's what they meant by movable anvil. Nice little tool. This is a half 13 bolt from Ace Hardware. And when we put that over the threads, got to get it centered just right. And I'm getting that turn just a little bit. I'm going to call it 445. 445. And I wrote down the dimensions for half 13, and the pitch diameter should be 450. So it's 5 thousandths off, but I'm sure well within the tolerance for the plating operation and the general use that a bolt like this would be used for. So that's how to measure. Let's do one more. This is a 5/8 hex bolt from Ace Hardware using the same micrometer. I like to turn those anvils in that direction. And I'm getting, let's see, 558 or 558. And the actual dimension should be 566, so that is about 8 thousandths off. And that's how to use a thread micrometer. And here's the final method, and I'm going to tell you about them, but I really can't do it, and I'll tell you why. These are called thread triangles, and they're little hardened triangles of a certain size. And these were supposed to be easier to use than the 3-wire system. And originally these came with a little rubber harness that could go around these pegs on the end, and then it would slip over the anvil and it would stay on the micrometer. Well, those failed within 6 months, as most rubber products do. But the main thing is there was a chart with this years ago, and the chart is long gone. I believe these were bought from Morel Mic, so I've had these in my toolbox, but they're really not usable. But let me show you how they are to be used. And this is how the thread measuring triangles work. They're most awkward to get on there. You're measuring across the flats into a 60-degree V thread. Now the dimension there is 780. That means absolutely nothing unless you have the chart to look it up into that came with the triangles that would tell you or convert that to the pitch diameter, because that 780 means nothing. And that's it. Choose your weapon. Those are the different ways of measuring threads that I have to offer you, minus of course the thread triangles. You can kind of forget about those, but I just thought that I'd throw them in anyway. That concludes this little video on measuring threads. I hope this was useful to you, and give me comments and subscribe, and so long for now.